right, this is first grade math, module 1, lesson 29. Today we're learning about taking apart problems, so taking apart subtraction problems with addends unknown. Okay, we're talking about different addition and subtraction problems. And we have to solve for the missing part. You guys need to be very quiet. I'm losing my voice because I'm trying to talk over you. Jimmy, put a bubble in your mouth, in your mouth. Put a bubble in your mouth, in your mouth.
This is so challenging. I really don't think I can even do this.
This is really hard, but I believe I can finish it. I'm going to keep trying different things.
It's so exciting. Brain growth happening right here.
They're trying to work on a problem.
Right, I'm just so excited.
Hey, what are you doing here?
Watching your super awesome brain grow right here, right now.
Really? What? Yeah. You believe in yourself and you're working on a really challenging problem.
What about me?
Well, you're also working on a challenging problem, but for some reason you don't believe in yourself. And that means that your brain won't grow as much.
What? You totally have the potential in yourself. As long as you start believing in yourself, your brain will grow a lot more.
Wow, I can do this. I really believe in myself now.
Thinking back in middle school, I got this message that was reinforced that I was good at things like reading and writing. Not necessarily directly told that I was good at things like math, and so never, believed in my math abilities, and as a consequence would be left behind. So Joe, I was doing some reflection about my own experience in high school. I was wondering if you could tell me about the research about the intersection between how the brain works and correlations with how well you do in math.
Yeah, it's really amazing actually. It turns out what you believe in yourself actually changes how your brain works. Some students have what's known as a growth mindset. Kids with a growth mindset believe they can learn anything. But some people have a fixed mindset and they think their intelligence is more or less fixed. So this graph shows you sets of students going through 7th and 8th grade, and it shows you their achievement. And the only difference between the two sets of students is their mindset. And you can see that the students with a fixed mindset, their achievement stays kind of level. But the kids with a growth mindset, their achievement's always going onwards and upwards. It kind of all takes off. I mean, it seems that if you believe in yourself, it actually changes how your brain operates and changes what you learn. It's just so important to believe in yourself.
My mom, who I lived with, didn't really know math well enough to be able to help me with my homework. We also couldn't afford a tutor. My mom was able to locate some relatively cheap summer options for me to, continue practicing math. As, 10, 11, 12-year-old, I was just like, oh God, like that's my summer, I don't want to do this. But I think those additional experiences helped me think about math differently. Once I started believing myself and seeing my progress, that I could actually keep up with what they were teaching as a 21-year-old at Stanford, and I'm just realizing that really helps get me where I am today.
All right, so did you guys hear what that was talking about? All of those kids who thought to myself, gee, this problem is really hard, but I'm going to keep working on it and I'm going to keep thinking about it, did so much better because their brains were able to grow and think more than those kids who said, boy, this is a really hard problem. Right? And that's the difference between, I'm not good at math and didn't even try. And that's the difference between a growth mindset, Danny, and a fixed mindset. Is growth mindset says, boy, this is hard, but I'm really going to work on it. And it's a challenge, and I'm going to challenge myself. And guess what? They do better than those kids who say, boy, this is hard, I'm not going to do it. Or boy, this is hard, I'm just going to, I can't do this. I'm not very smart. And guess what? Those kids who can do it aren't any smarter than the kids who couldn't. It was just a matter of mindset. Put that jacket over there. If you're going to treat it like a pillow, I'm going to try and nap during my class. It gets put away. Okay? So it's not a matter of smarts. That's not it. It's a matter of the ability and the will to work hard, and those who don't want to work hard. Okay? Hard workers do much better than those who don't want to work hard and who don't want to do the work, because their brains can't grow. Their brains can't grow if you don't do the work. And there's another video I was going to do. Ideas. I had this up yesterday and I thought, there we go. Growth mindset.
Chapter 1. Mojo discovers a secret about his brain.
Oh, but you guys
A
didn't learn the
secret that will
lesson, so we're
change the
gonna do it
way he
again.
looks at the world forever. Our story begins with Mojo, a friendly monster who loved school, especially math. Until one day, when something terrible happened. The math problems got harder. Nothing made sense anymore. Mojo had a devastating thought. He just wasn't smart enough for school. It seemed the only reasonable thing to do was pack his things and leave forever. Just then, he heard his friend Katie laughing. "Mojo, you can't just give up," she said. "I have no choice, Katie," said Mojo. "You're either born smart or you're not. And I realize today that I'm not." "Mojo, that's not how it works," said Katie. "Anyone can be smart. You just have to work at it." "That's the most ridiculous thing I've ever heard," said Mojo. "It's not ridiculous, it's science," said Katie. "Neuroscientists studied the brain for years and discovered an incredible secret, that your brain is like a muscle. When you try challenging things, like those hard math problems, you're giving your brain the exercise it needs to get stronger, which makes you smarter." "Oh, is that really true?" said Mojo. "Of course," said Katie. "It's like how when you were a baby, you didn't know how to talk, but you kept trying, exercising your brain, until one day you could." Mojo couldn't believe what he was hearing. If your brain was really like a muscle, did that mean anyone could become smarter? Even him? He turned to ask Katie, but just then, she had to be off to her next class. But maybe you can answer Mojo's question. What do you think? Can Mojo become smarter? What about you? Now that's an interesting question indeed.
All right, so I thought that was important for you guys to think about and talk about again, because I still kind of hear these kids and see these kids, you guys, who just want to sit there and do nothing. Max, the gloves and the hat need to come off. It's not that cold in our classroom anymore, so they need to come off so you can work. And you just want to sit there and do nothing. Guess what? Can your brain grow stronger if you sit there and do nothing?
No.
No. Your brain is a muscle. It needs to be used. And in order to grow stronger, you need to actually use it. Okay, so first graders, we're going to keep working on problems. Okay. All right, let me see. I got to turn this just a little bit so our first graders at home who hopefully watch these lessons afterwards, because for some reason they're not logging on and doing it live with us, and they can watch it afterwards. So, let's see. Ooh. Jimmy, your glasses are on the floor. That's how they're gonna get ruined. You need to put them on your face. Okay, let's see. Max had 9 pencils for school. He went, Oh, Mrs. Jack, I have to take this. Can you come and do the lesson? Thank you.
Hello?
Yes. The first problem is up there. You have to copy it. That's number 1, okay? Okay, guys. Shh. Sam, we're going to be very quiet so first grade can hear, okay? And second grade, you keep working on your math problem. Yeah, back to your spot, sweetie. Okay, so Lucas has 9 pencils for school, okay? So he has 9 pencils. Okay? He lends 4 of them to his friends. Okay? So let's say these are pencils. So I have 9 pencils, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9. He lends 4. Okay? He lends 4. Okay? So 4 of them. Okay. How many pencils does Lucas have left? Jimmy. 5. Yes. So he has 5 pencils left, right? Good.
You can't make lines with the pencil.
Yeah. Okay. So okay, we're gonna do another one. 6 children are a sleepover. You know, we're gonna do a number bond real quick with it, okay? Remember we were doing number bonds yesterday, right? Okay. So where does my whole number go? Max. Good job. And it goes on the top one, right? Okay, and that is the biggest number, which is 9. Good job. Okay, so what goes on my parts? Kimberly. And 5, okay? So then that turns into an addition, right? Okay, shh, please. Troy. Okay, so that's our number bond for that. Let's do another one, okay? Okay. 6 children are a sleepover. Okay. 4 children are wearing black shoes. Okay. And the rest are wearing white shoes. So there's a total of 6. 6 children. How many did I say are wearing black shoes? Danny. What was that? 4.
Jimmy?
Okay. The rest are wearing white shoes. Okay. So we have 6 children. The 6, yeah. Okay. And 4 are wearing black shoes. This seems like a little awkward.
Yeah. It's not as soft as the other one though, so it's like, well, I'll take it.
Okay. So that's supposed to be 2 right there.
Yeah.
Yeah.
Wait. So how many are wearing white shoes? We have 6.
Ooh, Max and Anaya have not been on it today. So I
Anaya.
think they're trying to use their growth brains here.
How many are wearing white shoes?
2.
2. Okay. And then the number bond. Yeah, okay. Cambry, what goes on the top?
6.
Good job. And then? Elizabeth.
Please no whistling.
And 4 goes into the tiny one.
And
2.
good job. Okay, so that means what? 4 plus 2 is 6, right? Okay. Oh, you did number 1? Okay. Okay, so I just did these 2.
Not too close.
What, honey?
What do I get? 200 total.
So do the next problem, right? You jump by the smallest one, like whatever one makes sense to jump by first. So like 200 to 425, you jump by hundreds first and then tens and then ones. But from 70 to 300, you jumped by tens and then hundreds. So just whatever one makes sense to jump by first. Okay. Thank you. This is Jack. Okay. Sorry, I've been waiting for that phone call from my doctor, so I couldn't ignore it. I had to call them, or I had to answer it. Okay, so I appreciate you guys being so wonderful to Mrs. Jack while she took over for me. She sat up nice and straight and tall. Cough, Danny. Jimmy, put those on your face. They do so much better on your face than on your desk. All right, wonderful. Okay, let's try another one. It's bedtime. It's bedtime. And 3 children are in their sleeping bags. The rest are underneath their blankets. Hold on. Very confusing how they did that. They never told you how much further to start. Okay. That's so funny. All right, we're gonna line this up straight in a row. Okay, we're gonna do our math drawing, and then we know, Jimmy, get out of your desk. Okay, I'm gonna tell your parents that you're refusing to wear your glasses. That's your choice. Okay. We're gonna line them up straight, and now 3 children are in their sleeping bags. 1, 2, 3. The rest are under blankets. Now we would need to decide how many are under blankets, right? We have 3 children in sleeping bags, and the rest are under blankets. So we do our math drawing to help us decide, and then we know we start with 6 children minus the 3 that are in sleeping bags. And however many's left are our kids under the blankets. Okay. So how many do we have left? Oh, Anaya, you're so on top of it right now. I can tell your brain wants to grow. 3, very good. And we know that also because if you guys know your double facts, you know 3 plus 3 equals 6, right? Go backwards with addition. So when we're doing our number bond, what number goes right here? What number goes right there? I love that I see so many hands. That makes me so proud. Danny.
6 in the bigger one, okay? And then what about the two smaller ones? Max? What? 3 and 3, very good. Does it matter which order I put them in? No, because they're the same number anyway, but even if they're different, it wouldn't matter, right? Give yourself a pat on the back if you knew that. Very good, very good. Let's see. We're gonna keep going. All right, we have 8 cupcakes in all. 6 of them have chocolate icing. The rest with vanilla. How many cupcakes are with vanilla? So how are we gonna solve this problem? What could we do? What are we gonna do? Miranda?
Count backwards.
Okay, so we totally could. What's the problem that we should write down? What's the subtraction problem that we should write down?
Wait, how much could this do?
Okay, I'm gonna say it all again. So you guys listen very carefully. You have 8 cupcakes in all. 6 with chocolate icing and the rest with vanilla. So what's the problem? Cambry, you wanna give it a try? Okay, please don't rip off your name tag. It drives me nuts, man. I take that down for a reason. Okay, Miranda, try it. What's our problem?
So 6 that have nothing on them. So the rest,
How many did we say there were all together?
8. So what equals 8 is you count.
Okay, hold on. I don't want you to solve it yet. I just asked you for the problem that I could write down.
You can write down 6 minus 2.
No, hold on. Okay, so what you want to know, you want to start with your bigger number, 8. Our total is 8, and we take away the 6 that we already know, equals what? If you want to do an addition problem, just like then you would say, okay, if I have 6 chocolate cupcakes plus how many vanilla cupcakes equals 8. Okay? So very good. We weren't solving it yet. I just wanted to know my problems. Okay? Very good. So I could do a math picture with this, math drawing. Am I going to draw the most fancy cupcakes in the whole world? No. I'm going to do 1, 2, 3, 4, 5, 6, 7, 8 cupcakes, just circles. And I'm taking away 6 of them, right? 1, 2, 3, 4, 5, 6. Okay? And how many do I have left? Oh, I see lots and lots of hands. Thank you, Jimmy, for deciding to participate. Sit your body down and then you can answer it. What, Jimmy?
It's 2.
2. Very good. And that would be correct for this, and it would also be correct for this. Okay? And as Miranda said, if I could find where my number line went. I had a number line over here. Well, I can't,
Look around.
I wonder where my number line went. All right, I'll just write one. I can do that, right? 1, 2, oh, what? Miss Kennison. I said 2, wrote 8, silly me. 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. I solved my problem. Easy peasy. Couldn't find. I made a number line, and I saw my mistake when I goofed up and made a silly mistake. Okay, so for 8 minus 6, I would start at 8, and I'd count backwards 6, right? 1, 2, and notice I don't count the number I'm on, Danny. Sit up. I don't say 1. I make that hop. 1, 2, 3, 4, 5, 6. I land on 2. Very good. If I was doing 6 plus 2, I'd go 6, and I'd count up. 1, 2. Okay? So either way, I get the correct answer, whether I do a math drawing, whether I do it on the number line. Sometimes I could do both just to check my work. Okay? And then we would write our number bond. Our number bond Excuse me, please don't stomp your feet. It drives me bonkers. Drives me absolutely bonkers. In my number line, where are my numbers gonna go? Who can tell me this? Elizabeth? Okay, and what one's the bigger number? Amy, I need you to scoot back. Like you and Jay are way too close. 8, very good. Thank you, Elizabeth. Okay, and then I have 2 more bubbles. What's gonna go in those, Cambry? And? Do I have 2 6s up here? No, I do not.
You have a 2.
I have a 6 and I have a 2. Does it matter which order they go in? Nope. 6 and 2, or I could do 2 and 6. It does not matter. It does not matter. Or I forget, I want to do 1. Oh, I guess it's 1. Is 18. 18. Okay. In your guys' work sets today, that's what you're doing. Okay? We're doing word problems that then we put into excuse me, Jimmy, I cannot be talking over you. I love you, I love you, I love you, I love you. I can't be talking over you all the time. I need you to be quiet and listen, please. It hurts my voice to try to talk over you. Okay, so we're going to do a couple more real quick, and then you guys are going to do some on your own. Okay? There are 7 sneakers in all. 3 are with Velcro. The rest are with shoelaces. Okay, how many? And then we're going to find out how many we have with shoelaces. So we're going to talk about our total. We've got 7 sneakers in all. So we know that that's our biggest number. So we know that's where we're starting with, right? And then who remembers how many were with Velcro? Anaya? Uh-oh, my brain quit on me. Uh-oh, girlfriend. Cambry? I got friend. Thank you. Thanks. Okay, we need to put on our better listening ears, first graders. Okay, nobody heard me. And it's because you guys are all messing around. Jimmy's playing. The rest of you guys are in like, Miss Kennison will do it for me. No, I already went to first grade. You guys are supposed to be working on your math brains, making them get stronger by doing the work, right? So listen carefully. 7 sneakers are in all. 3 sneakers have Velcro. The rest have shoelaces. Okay, so how many do I need to subtract in order to find how many with shoelaces? Put your mask on properly. Elizabeth? Gosh, I don't know why this one doesn't register. Okay, 7 minus 3. 7 minus 3. Let's do a math drawing to solve the problem, okay? You need to take your hand off of your mask, though. That's not good. 1, 2, 3, 4, 5, 6, 7. Okay. All right, and then we're going to cross out 3 of them. 1, 2, 3. Or you could go 1, 2, 3. It doesn't matter. And how many do we have left? How many do we have left? All right, Jimmy, how many do we have left? 4. 4, very good. So our answer would be 7 minus 3 equals 4. Okay, where did my numbers go in the number bond? Danny?
So the 7 goes in the big one.
The 7 goes in the big one because it's the biggest number. Okay, and what happens to the other 2? Miranda.
So you put 3 and 4 in the little ones.
Right, and does it matter which order we do it?
No.
No, because
My poor brain, man. Gotta keep working on it hard, huh? Make it grow stronger. 7 minus 3 equals 4, or 7 minus 4 equals 3. Because 3 plus 3 equals 7, or 4 plus 3 equals 7. Okay?
3 plus 3 equals 7.
Did I say that? My goodness. 3 plus 4 equals 7, or 4 plus 3 equals 7. Okay. All right. We have 10 coats. 7 are with buttons. The rest are with zippers. So in order to find the ones with zippers, we say there's 10 coats. We take away the 7 with buttons, and the rest will be with zippers. Okay? So we can do our math problem, our math drawing in order to help solve our problem. Our math drawing. So we're going to draw 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're going to cross out how many? Avery?
4.
How many am I going to cross out? How many is in my problem? Fix your mistake. I start with 10. How many am I taking away, Cambry? Okay, so that's how many we're crossing out. Maybe you're trying to give me the answer. I wasn't asking for the answer yet. I was just asking for how many we're taking away. And that says it right there in our problem. So did your brain change and think a little bit and grow? Oh, good. Okay, use your mistakes to solve your problem. 1, 2, 3, 4, 5, 6, 7. And how many do we have left? What is our answer now, Cambry? What's our answer now, Cambry?
3.
3, there we go. All right, Max, where am I putting these numbers in my number bond?
Circle.
What goes in the bigger circle?
10.
10, okay.
And 7 and 3 go on.
And does it matter which order they go in?
No.
No, because 10 minus 7 equals 3, or 10 minus 3 equals 7, or 7 plus 3 equals 10, or 3 plus 7 equals 10. Doesn't matter which order you do it in for addition. It doesn't matter. All right, very good. Pat yourselves on the back. Okay. On this, you have to fill in the missing numbers. Okay, you get to do your own. You get to do your own on this first one. You get to make your own. It says, Danny, pay attention. It says there are blank apples. Well, how many apples are there? Count them. And then it says blank have worms. Well, how many apples have worms? Count them. Then it says how many good apples are there? So you need to use the picture to help you write that in there. Okay? First graders at home, please pause the video to take a look at your worksheet. And then you can write it down and send me this stuff on Class Dojo. Okay, the second one says blank, stop, please. I cannot talk over you. Blank books are in the case. You're going to have to count them. Okay, and then it says blank books are on the top shelf. You're going to have to count the top shelf of books and put how many are there. It says how many books are on the bottom shelf. So you're going to have to solve that whole problem. On the back, and once again, first graders at home, pause the video and have your learning partner, your grown-up, help you read and figure out what you're doing here. But you need to solve the problems. Okay, there are 8 animals at the pond. 2 are big, the rest are small. How many are small? You need to write down your problem, do your number bond, do your math drawing, solve the problem. The next one, it says there are 7 students in class. Blank students are girls. You get to come up with your own number, but it has to be less than 7 or less, right? Can't just be like 19 kids are girls. That doesn't make sense. How many students are boys? Okay. All right. So that is what you're doing. When you guys finish, we'll turn it in on Class Dojo. And and then get on to Zern.
Okay? All right, thank you first graders who are working from home. I hope you go back, pause the video on those problems and do them on paper.